Okay, welcome back. So in this video I'll be talking about logarithms. So logarithms is another part of functions and a part of algebra. So logarithms in this video I'll explain you about the basic concepts of logarithms, and in the following videos I'll explain some logarithms with some examples. So a logarithm is actually a representation. So logarithm is used to compact elements. That means it means to reduce the size of elements. So logarithms are used in most parts of physics and chemistry. So it's physics and math. So it's important to learn the logarithmic equations, the logarithmic basic concepts, and the laws from the beginning. So as I explained what is a logarithm, you can say now if you have some power like this. So I explained about powers in my last video. So if you have a powers and indices like this, so you know that 3 to the power 4 is 81. So 3 to the power 4, if you have not watched that video, 3 to the power 4 is 3 times 3 times 3 times 3, 3 multiplied 4 times, and that is equal to 81. So we take the logarithm like this. So logarithm has three parts. One is the logarithmic term, or this log term. So this log term is a common term for all the bases. So this part which is hanging down here is called the base. Now example, you can take the logarithm to base 10, logarithm to base 3, logarithm to base 2, anyone, even 10,000, even millions, any real number you can take. But you don't take normally logarithms to minus bases, you take only to positive bases. So in this example I have taken logarithm 3 from both sides. So if I take log 3 from both sides, that will be log 3 to power 3 to the power 4, and that will be equal to log 3 81. So as in the case of doing some operations on equations, if you take logarithm on one side of an equation, you have to take on the other side as well. So that's what I have done here. So log to the base 3, because I have used this because I can get a complete integer that takes a common logarithm than to base 4. So I'll explain that in the concepts when I am explaining you about the basic rules of logarithms. So log 3 to base 3 to the power 4 is 4 times log 3 to base 3. So that will be explained in another video. So explained in this video in another slide. So I'll explain that. But for now, remember that log 3 to base 3 is 1. So 4 times 1 is 4. So log 3 to base 81 is 4. So what's important here is not the value that you get here, or also not the value of the base or the way you get it. What's important here is that if you have this one in the form, say 3 to the power 4 equals 81, you can rewrite this. You should be able to rewrite this equation in the format of log 3 to base 81 equals 4. So if you have some power a to power b is equal to c, you should be able to take log from both sides and tell that b is equal to now a to power c. So that's the way. Now for another example, if you take log 5 to base 81, it is not equal to 4, because according to the rules of logarithms you can say that this one is not a perfect number. So having explained about all these, I can summarize this relationship into a simpler format like this. So if you have log a to power b, log b to the base a equals c, you can rewrite and say that b is equal to a to power c. So if you have log 10 to base 100, so 10 to base 100 is equal to 100. So if log 10 to base 100 is equal to some value, 100 is equal to 10 to power c. So you know that 100 is equal to 10 to power 2. So 10 to power 2 equals 10 to power c. So 2 equals c. So log 100 to the base 10 should be 2. So that's a simple relationship between the powers and logarithms. So what generally happens here is that in the case of transiting between these two, between a, b and c, what generally happens is that you keep this value like this, and then this a is moved to this position, and the c, which is on the right side of this equation, is made a power here. So you have a power here, so b is equal to a to power c. So you keep the b here and then take a here and make c a power and equate both sides. So that's the general relationship between powers and logarithms. So you may have already understood and identified by now that logarithms are used to compact elements. Now if we have 3 to the power 4 equals 81, what we do here is we actually expand this term. So 3 to the power 4 is equal to 81. So 3 and 4 are just small integers, but 81 is a large integer. So you expand this one. When you take the log 3 to the base 81, right, log 3 to the base 81 is again reduced to 4. So logarithms are used to compact elements. So having explained about a brief introduction to logarithms, let me now explain you about the rules of logarithms. So there are various rules of logarithms. Now as in the case of limits, powers and every other concept on algebra. So you know that there are various rules. There should be rules when you multiply different logarithms, different parts of logarithms, when you divide, when you add those. So those are the same in the case of logarithms as well. So the first rule that I will be explaining you is the power law. So what do I mean by the power law is that when I multiply two terms inside a logarithm, what happens to that? So to explain that, let me take a simple example. So I'll consider two values x and y, where log x to the base 10 is p and log y to the base 10 is q. So from the last example or the last relationship we build up, we can say that now x is equal to 10 to the power p and y is equal to 10 to the power q. So x equals 10 to the power p and y equals 10 to the power q. So when I multiply x and y, I can say xy is equal to 10 to the power p times 10 to the power q. However, you know that 10 to the power p and 10 to the power q, so the base here is both 10 here, right? Here the base is also 10, here the base is also 10. So you know from the laws of powers that when you multiply two indices whose bases are similar, you can add those. So 10 to the power p times 10 to the power q can be written as 10 to the power p plus q. So the next part I will do here is that I will take the logarithm to the base 10 of both sides. So as I explained, as in the case of all the other equation operations, if I take logarithm of one side, I have to take the logarithm of the other side as well. So if I take the logarithm of both sides, I can say I can keep this term and then solve for this term. So log 10 to the base xy is equal to log 10 to the base 10 to the power p times 10 to the power q can be simplified to 10 to the power p plus q. So this p plus q can be taken here, so that I will explain in one of the other rules of logarithms. So for now, generally assume that if you have something like this, log a to the base b to the power c, you can write that as c times log a to the base b. So p plus q times log 10 to the base 10 is 1, so that will be p plus q times 1. So log 10 to the base xy is equal to p plus q. Now p and q are values that I took from a substitution here. So I can do the reverse operation and substitute for p and q. So p is equal to log 10 to the base x, q is equal to log 10 to the base y. So you can say that log 10 to the base xy is equal to log 10 to the base x and the addition of that to the log 10 to the base y. So what's important here? So if you have two terms you multiply inside a log, now you don't need actually the base to be 10, it can be 2, it can be 3, it can be 5, any base, right? Log to any base, if you have a product inside that log, what generally happens is that we write the logarithm to the same base of the first term x here, plus we have to add that if you multiply, as in the case of powers, if you multiply you have to add the indices, and here also if you multiply you have to add the logarithms, and you take the log to the same value, but now the value you take is the second term. So similarly you can write finally log a to the base xy as log a to the base x plus log a to the base y. So if you have log 10 to the base 10 times 20, which is 200, so log 10 to the base 10 times 20 is equal to log 10 to the base 10, which is 1, plus log 10 to the base 20, so that is equal to 10 times 2. You can further simplify. And also what's interesting here is that if you have three terms here, log 10 to the base x, y, z, you have to take the individual logarithms of those terms and you have to add those. So another function that you can see here is the division. So I explained about the division of powers and indices in the videos on powers and indices, and I did some sample videos, the questions, sample questions in fact. And you can do the same operation for logarithms as well. So if you have two terms x and y, so I'll take log 10 to the base x equals p. Similarly, log 10 to the base y equals q, as I did in the multiplication theorem. So from the powers and indices and the relationship between the powers and the logarithms, you can say x equals 10 to the power p and y equals 10 to the power q. So when you actually consider the quotient of these values, x divided by y is equal to 10 to the power p divided by 10 to the power q. So by taking the logarithm of both sides, we can say that this is equal to log 10 to the base x divided by y is equal to log 10 to the base 10 to the power p divided by 10 to the power q, right? So you know that 10 to the power p divided by 10 to the power q, so their bases are equal, but their powers are not equal. But you know from the concept that you learned under the rules of the indices, that if you have the same bases but different powers, and when you divide those, you can subtract the powers keeping the base constant. So you can say that 10 to the power p divided by 10 to the power q is equal to 10 to the power p minus q. So this can be solved up to here. So log 10 to the base x divided by y is now equal to log 10 to the base 10 to the power p minus q. So this is equal to p minus q times log 10 to the base 10. So that is equal to p minus q. So from substitution, we can say that log 10 to the base x divided by y is that p is equal to log 10 to the base x and q is equal to log 10 to the base y. So finally, log 10 to the base x divided by y can be simplified to log 10 to the base x minus log 10 to the base y. As in the case of multiplication, this operation is not limited to the base 10. This can be to any base. So generally we can express this to a base a, whose value a can take any positive integer. So log a to the base x by y can be simplified to log a to the base x minus log a to the base y. So if you have three or four terms that you have to take the divisions or the quotient, what you have to do here is that you have to divide in the format like this. So you can subtract and subtract and subtract and go. So you have to divide into a format like this. So if you have a multiplication, you have to take brackets and solve it for that as well. So that's about the division and the multiplication. So I have been using this concept throughout this video. So what is this log 10 to the base 10 to power here 10 to power p minus q? How does that equal to p minus q? And log 10 to the base 10 to power p plus q here equal p plus q. So that is explained in this slide. So the third rule explains as to why that happens. So if I have some function like this, x equals 10 to power p, so I need only one substitution and one variable to explain this. So if x is equal to 10 power p, and if I take that to power q, so if I take x times x times x times x up to k terms, that will be equal to x to power k, and the right side will be 10 to power p times 10 to power p times 10 to power p, and that will be k terms, and that will be 10 to power p to the power k. So you know from the theories that you understood on the rules of powers and indices, 10 to power p to the power k is equal to 10 to power pk, because you know that if you multiply two powers, you have to actually multiply it individually. So 10 to power p times to the power k is equal to 10 to power pk. So the next step would be, as in the case of multiplication and division, I'll take the logarithm for both sides. So since I have 10 here, I'll take logarithm to base 10 here. So logarithm to base 10 to power x to power k is equal to logarithm to base 10 to power 10 to power pk here. So that is equal to pk here. So what generally happens here is that you can say that log 10 to the base x to power k is equal to k times log 10 to the base x, right? So as a general rule, we write this as log a to the base x to power k is equal to k times log a to the base x. So that is the reason as to why we got log 10 to the base 10 to power p minus q as p minus q, and log 10 to the base 10 to power p plus q as p plus q. So that's the third rule. And another rule of logarithms is the changing of base. So there are actually two rules for changing of base. So I'll explain both rules in this slide and in this video. So to explain that, I will take another example, a substitution. So I'll take x equals a to power y. So from the concepts of logarithms and the relationship between logarithms and powers, you can say that log a to b, if you have x equals in the format of x equals a to power y, you can rewrite in the log form as y equals log a to base x. Now what happens when we consider the changing of base from a to b? Now you know that x equals a to power y. So what generally happens here is that log b to base x should be log b to base a to power y. So log b to base x is equal to now y times log b to base a. So that's from the third rule. So y is equal to now log b to base x divided by log b to base a. So you know that y is already log a to base x. So you can say that log a to base x is equal to log b to base x divided by log b to base a. So finally we write that as follows. Now when x equals b, so what generally happens is that b equals a to power y here. So here we have log a to base b equals y. You can rewrite this as log b to base b is 1. So log a to base b is 1 upon log b to base a. So what generally happens is that you can write log a to base x in two formats. So this is not only when x equals b. You can also write log a to base x as 1 upon log x to base a. So if you have say log 10 to base 100, so you know log 10 to base 100 is log 10 to the base 10 to power 2, so that is 2. So you can also write this as 1 upon log 10 to the base 100 as 1 upon log 100 to the base 10. So 10 is 100 to the power minus 2. So when you take the upper value, you can say that is 1 upon half. So 100 log 100 to the base 100 to the power half. So that will be 1 upon half, which is 2 again. So both are correct. So generally you can say that you can change the logarithm into two ways. One way is that you can change the base completely. Now in this case you change the base from a to b completely, and the second way is that you can keep the base intact, but you can change the base and the values here. So b comes here, a comes here, but you have to take the inverse of that. So for this example I can take log 10 to the base 25 is equal to log 5 to the base 25 and log 5 to the base 2. So I have changed the base from 2 to 5 for the first example, and that is equal to log 5 to the base 5 to power 2. So that is equal to 2 times log 5 to the base 5, which is 2, divided by log 5 to the base 2. So that is equal to 2 by log 5 to the base 2. And in the second method, according to the second method, I can write log 2 to the base 25 as 1 upon log 25 to the base 2. So you can find these values and prove that they are equal in magnitude. Now, having explained about these rules and the laws that govern the logarithms, let me explain about the types of logarithms. Now, although there are various types of logarithms, I explained to you that you can change the base from 2, 5, 10, 100, million, anywhere. But for most occasions, we use only two types of logarithms. One type of logarithm is the common logs, which is to the base 10. So I explained that throughout this video, log to the base 10. And the second type is a special type, and that is not actually an integer. It's exponential function. And we call that type of logarithm as the natural logarithms. The natural logarithms, since it is using an exponent function, we denote that to be base e. So in the case of common logs, we denote that to be base 10, log to the base 10. And in the case of natural logarithms, we denote that to base e, log to the base e. Sometimes this log to the base e is also called ln or ln, and log to the base 10 is called lg. You can prove that there exists a great difference between log to the base 10 and log to the base e when you draw graphs of such logarithmic functions. So I will not draw the graphs here, but you can prove that, and you can observe the differences and how these logarithmic values vary when we take different values, and how these logarithmic values help us to shorten the values that we get. So the final part of this video I'll explain about the logarithmic equations. Now in the concepts of linear equations, quadratic equations and all the other equations, I explained about various types of equations. So another type of equation is the logarithmic equations. So logarithmic equations are used to solve values, but they are actually only limited to logarithms, not to other components of physics and math. They are only limited to algebra or logarithms. So logarithmic equations are very simple. Now you know how to solve linear equations, you know how to solve quadratic equations, and you can also solve cubic, quadratic, any equation, right? Okay, cubic and other powers as well, using factor theorem, remainder theorem. There are various methods, long division, various methods that I described in my previous videos. To solve logarithmic equations, you have some equation like this. What you do here is that you use the logarithmic laws or the rules to explain what is going on here, and then you equate both sides. You create some log term here both sides, and those all the values you make sure that all the values you have taken are inside these logarithms, not as a coefficient, not as any other power or something like that. So you have two logarithmic terms, so you have two values. Then since the logarithmic values are now we are taken to the same base, you can finally say that the values should be equal, and then you equate and find that value. So if, for example, I have presented here an example, ln or log e to the base 36 plus log e to the base x equals 2 times log e to the base 12. So if you are given some sample problem like that, you can say then now that now we have an addition here. So from the reverse reaction of multiplication, you can say that this is equal to the multiplication of two terms inside the logarithmic base. So log to the base a plus log to the base b is equal to log to the base log something to base a times b. So you can rewrite, or you can go for the converse reaction, and you can show that this ln 36 plus ln x is equal to ln 36 times x. Also, from the third law, you can say that if you have some power like this, a coefficient like this, you can take this coefficient here and make a power of this value. So you can write 2 times the ln to the base ln 12 as ln 12 to the power 2. So as I mentioned at the last step, what you do is that since the bases here are equal, so ln is log e to the base 36 times x is equal to log e to the base 12 to the power 2, or 12 squared, 144. So since the bases are equal and the logarithm terms are equal, we can equate the values inside this. So you can say 36 times x, or 36x, is equal to 12 squared, or 144. So x is equal to 12 squared, or 144 over 36, which is 4. So that's it about the logarithms. So in this video I explained to you about the introduction to logarithms, rules of logarithms, types of logarithms, and finally the logarithmic equations. So in the next videos on logarithms, I will explain you with some sample examples that you will face when solving problems related to logarithms. So thanks for watching this video, and see you then.